No, most. Some means mirroring, but those probably no. Okay. Okay, but it's not running there, so it's okay. I'm not sure if it's something that it works. Okay. You want to do this way? You want to read?
Shall we start or?
We are ready, so.
Okay. Okay, let's start then. It's 3. Let's have a small introduction about myself. I'm Anish and I'm the part of Fedora as well as Red Hat's IIT team. With me is Mike, he's my colleague as well as friend. And we both work for Fedora as well as Red Hat. Mike. It's better now. So let's start with today's topics. So today we're going to talk about what our input methods are, then specifically why predictive input methods are required, then a small theory behind it, and the projects that we are working right now to implement such input methods. So let's start. What are input methods? Because basically I normally don't show these slides when I talk in front of Asian countries because they use input methods on their day-to-day basis, but as I'm in Europe and mostly European people don't know how to use input. They don't use input method as such because most of the European people, they use some kind of keyboard layouts, different keyboard layouts, such as for if you want to write the French, then you have the French layout, XKB layouts kind of thing. So let's talk about what our input methods are. So I just, it's not 100% or dicto kind of slides that I would just want to differentiate between the types of input methods. So according to me, there are two types of input methods. First is character-based input methods, and other are sentence-based input methods. So what are character-based input methods? So those kind of input methods are nothing but when you type one character of ASCII or Latin, then you would get alternative character for that particular language. So typically we use such input methods for Indian or Korean or Vietnamese languages. And second type of input methods is Chinese or sentence methods. I call it as a sentence-based input methods. For example, Chinese or Japanese. Why this is the difference between the characters? But I would like to demonstrate more about what are the differences between the character-based input methods and the sentence-based input methods. In languages such as Japanese or Chinese, where you have more than 2,000 characters, it's really difficult to guess, like to type all those characters with 36 letters. So to solve that problem, what generally user does is he types certain characters, say ABC, and then he presses space key, and after pressing the space key, the user normally would get different kinds of suggestions, out of which he can choose which are the probable candidates or probable words. Maybe Mike can demonstrate to you so that you would feel like what I'm trying to say, what I'm trying to say. Maybe Mike, you want to say something about it? Maybe there's Mike as well.
So, for example, if one wants to type something like Japanese, one usually types Latin alphabet. Oh, it's not. Why doesn't it work? Shit. No, it doesn't work. Maybe I have to restart gedit.
So it's always the thing.
How it works? Why doesn't it work in gedit? So I type it here. I type Latin alphabet and get Japanese phonetics, and then I have to press the space key to get possible conversion candidates. And you don't have that extra step in languages like Indian languages like Marathi, or if you type Russian via transliteration, or Korean, because then the Latin string you type has an exact conversion to the target language already. So this conversion step is not there. And I think that's what Anish meant with sentence-based conversion, because in here you see you have many candidates you have to select, and if you type phonetics longer without the conversion step and do the conversion later, then there's more context, and an intelligent input method can do the conversion more correctly on first try, depending on the context.
Yeah, I don't think so. And there's one more difference between sentence-based input methods and characters-based input methods. In sentence-based input methods, you don't have a space in between the two words. So for example, in Latin languages or ASCII languages, you always, after typing some word, any word, you type space key for the space. But in Chinese or Japanese, you don't have a space in between the words. So that is one of the important.
That makes it quite a lot harder to parse Chinese or Japanese into tokens if you want to predict the next word the user wants to type. In English, it's clear what the word is. The words are separated by spaces, but in Japanese, one would need to parse the typed stuff and to parse it into tokens. So our prediction input doesn't do that yet, so it works only for languages which have spaces and
Yeah.
clear separations between words.
And the reason behind we have such kind of slides and such kind of demo because we want to have the predictions available to all the input methods, not only to the, not restricting to the Asian languages or to the European languages, but for the all desktop as a platform. So that is one of the goal of this project. So what is the current state of input methods? How users generally feel when they use the input methods in the current, on the desktop. So generally when I observe that when I type using, by the way, English is not my native language, and when I type something, when I create a text using the, or when I chat with my friends using any like Google Plus or something, I always make such kind of face, and that is true, because whenever I type something, I always get red marks. Those red marks that means that I had typed something fear or my spelling, whatever I typed the words which I had typed in the past, I made a terrible spelling mistake, and I always do that because English is not my native language. And I observed in most of the users where mostly particularly for the multilingual users where you are particularly very good at one language, and when you switch to the different language, it's really difficult to remember all the words pertaining to the language. So that is one of the use cases which we are targeting, and another use case is ease of typing. So generally, for example, if you are using the Android or iPhones, users usually don't type the long sentences by themselves. They just press the next like on the screen. You just click on the screen so that you will get the next suggestions. So these are the one of the project use cases which we had in the mind, and that is why we started this project a year back. So let's see. And of course, I'm not talking about keyboard because some of my friends, they are really good at keyboard and they just type fast. They often complain to me that why you need such kind of input methods like prediction, text prediction. We really don't need that because we type at the speed. And generally, oftenly they say we type at the speed of light, so we don't need such kind of input methods. But again, there is one more use case for that. Right now, we are currently supporting the touch input or touch screens as well for desktops. So for that, you need to have text predictions as well. And to support such kind of modern hardware, we require text prediction as such. Of course, the need, all these stories which I have told you are related to the user stories behind it. But let's look at the statistics. Say India has 1.2 billion of population, out of which 70% of them can read and write any language, and out of which 5% only understand English, and 51% of the youth in India, out of that population, 51% of the youth of the population is young and youth. They really want to use the computers, but they are not the programmers. But they want to use the desktop or the computer. And if you calculate the status, if you do the calculation or the math, then the actual figure, which consists of millions of users, and these millions of users are not actually programmers, or no, they're just average computer users. They want to type something on their computer, and they need some kind of input methods or a predictive input method so that their life would be easy. And of course, I really want to talk about the diversity, especially when it comes to India. India officially supports 22 languages, out of which we have 9 major scripts, and all these scripts and languages are supported in Fedora. Let's talk about the rest of the word as well. Somebody had blogged about in Fedora project in maybe last month or something, so I took the references from that. The list of endangered languages. Currently, there are many languages that are on the verge of extinct. And if you really care about languages, if you want to really digitize those languages, one of the ways to do that is have a prediction available to that languages, so that it would be easy for users to type and the users will be motivated to use that language. Then a bit of theory behind this predictions. If you are interested in it, like, are you interested in the theory or listening to the theory behind it? Yeah, thank you. Because it's kind of it's not a magic that how you predict the next word when you type the previous word. Because in the morning we had a conversation with Mike and our manager, Anish Peterson, regarding what is in the next Fedora next. And while in conversation, we had literally interesting sentences. A sentence made by a famous basketball player.
Some American baseball player, Yogi Berra, said that prediction is hard, especially about the future.
So it's really hard to predict the future, especially because if you can predict the future, then we will be God. So we will be not talking here, like, because we are the God. So it's not a magic. So how we can guess how we can predict the future? It's really interesting. Like, for example, if I ask you, would there be any rain today? What would be your answer? Any yes, no?
Probably not.
Why?
Well, we don't know exactly. We can guess that from looking at the sky that probably won't rain.
Yep.
The chances reduced.
Yes, that is the theory behind the text prediction. It's a probability. It's not the perfect theory. So when you say today it won't rain, because why? Because the sky is clear. And if perhaps somebody would answer, okay, today it would rain. Why? Because temperature is damp. Though the sky is clear, yesterday it rained. So maybe today it would rain. So it's like the probability. What is the probability that it would rain? So how we calculate it is depending on the previous data, or the previous data as well as the current conditions. So we both combine all these data and we decide, okay, today is probably not going to rain. So similarly, while in text prediction, we assume something similar like this. So in text prediction, what we do is we generally store the previously typed words by the users, and depending on the previous typed words, we can guess what would be the probably next word. So there are couple of techniques. One is statistical techniques and other is probability theory. So we use those two techniques to determine what would be the next word or what would be the probable next word. Excuse me. So let's look at what are those techniques. So one of the technique is language model. So if you have heard about the corpus, corpus is nothing but a big collection of data or big collection of sentences. So for example, if we say Wikipedia has thousands of lines of sentences for English language. So we call it as Wikipedia is nothing but it's a big corpus or collection of sentences. So using such big corpuses, we create the language model. And in this language model, there is a kind of interesting story, like interesting sentence, which I had shown in, which I had written in this slide. That given a corpus or given a language, what is the probability that one word would follow another word? For example, right now, if I say Fedora, what would be my next what would be my next word? Can you guess? Say Fedora eats. What would be my next word?
Fedora next, maybe.
Yeah, maybe Fedora next, or Fedora is, let's say, awesome. Okay, so that's what. So if I would have said my next word would be AWE, then you would probably guessed, okay, it's awesome. Why? Because more like, yeah, like in back of your mind, you would be guessing that, okay, what would be the words which I have started from AWE, and in this context, it's like, okay, Fedora eats. So kind of like that.
According to what I read in the book The Language Instinct by Steven Pinker, if you cut a typical English sentence somewhere in the middle, then the number of words which could possibly follow are on the average in the order of about 10. So it's not such a which would fit into the sentence, making it correct grammar. So if you look at the past, what has already been typed, it should be possible to get it down to a relatively small number of candidates, which makes sense.
So the simple model is nothing but the number of occurrences. It's a probability. Probability is nothing but number of occurrences of a particular word and the number of words in that language. So it's like, okay, let's take an example so that you will get to know. And there is one more theory behind it. It's a kind of, all these things are typically mathematical things. So I'm trying to present in a simple way as I can. Let be patient with me. So Markov models is nothing but probability of the word depends on the probability of n previous words. That is basic thing, or there's a basic basic principle behind the probabilities. Let's take an example so that you can get what I'm trying to say. Say I have a big corpus in which, or small corpus in which, small would be the appropriate word for this, 3 sentences. First sentence is Fedora is awesome. Second one is Flock is awesome. And third one is Flock conference is awesome. And just forget start and stop. Start or stop is nothing but to understand the sentence has been started, and stop is nothing but they are just special symbols to know that the sentence has stopped. So in this training set, let's grab a vocabulary. Vocabulary means the words which are unique in the training set. So in this corpus, vocabulary is start, then Fedora, then Flock, then ease, awesome, stop, and again the conference. These are the unique words in our corpus or training set. Then let's start with generating our language models. Say unigram model. A unigram model is nothing but a unique word, like only one word. Say Fedora or ease or awesome. These are called as unigram models. Bigram models means a set of 2 words. For example, Fedora is called as bigram model. Trigram, it's similarly set of 3 models. So if you go on till nth time. So let's calculate the probability of Fedora, the word Fedora, in the entire corpus. So its probability is 1 divided by 16. How it is? Because the number of occurrences of Fedora in the entire corpus is only once. And if you divide the number of words in the vocabulary, it's 16. So its probability is 1 divided by 16. So similarly, if you calculate the probability of word ease has occurred 3 times in the entire corpus, and the number of words in the corpus are 16. So it's 3 divided by 16. So it's just like I have just made the unigram model for this small corpus. So similarly, if you want to try for the trigram model, so the trigram model is nothing but the set of, as I say, the set of 3 words. So say what is the probability of the word flock which occurs at the start of the sentence? Do you get what I meant to say? So here the word flock has occurred at the start of the sentence. So I want to calculate the probability of the word flock which has occurred at the start of the sentence. So its probability is 2 divided by 3. Why? Because we have 3 sentences and we have a couple of occurrences of the particular case. So similarly, if you want to generate the trigram model for the entire collection or entire sentence, how you can do it is you need to apply this formula for the sentence. And what I did in this sentence, the whole sentence. So if you want to apply the trigram model for the entire sentence, how it should be like probability of flock, then the start into probability of the word is, then probability of the word awesome, followed by the probability of the words is and flock. So if you go on calculating if you go on calculating such probabilities, then you will get a language model. What is really difficult is how you should for a corpus or to build a language model offline, it's relatively easy. But when the user types and at the runtime you need to update or you need to build such language model, it's a kind of tedious. That is one of the difficult or challenges behind such projects. So to overcome, so whatever I just told you, all these are theory. So let's look at the practical. So we started a project called iWords Typing Booster. iWords Typing Booster is nothing but a text prediction for the all input methods. It's also support the direct keyboard input. For example, if you are using, say, French keyboard, and still you can use the iWords Typing Booster to get the predictions. For example, if you are using do we support Italian as well? I guess. Yeah. Or if you want to type the German or Italian language, you can use the iWords Typing Booster to get suggestions. That is one of the goals of this project, that we should support all the available input methods. And also we support some transliteration, then the phonetic, iTrans, InScript. I'll not go into details of all those things. Why? Because maybe those things are not interesting to you. If you want to know about it, I can say later. And one of the goals of this project is users normally had to learn new things, and they have generally a big resistance for the new things. So you don't have to. Excuse. That is one of the goal, and another important goal is to improve the typing experience and let users to enjoy the data creation in Indian languages as well as European, in any language, with the boost in typing speed without compromising on data accuracy. Also, it supports all the locals, and it's basically the suggestions what you get are directly come from Hunspell dictionaries. And technology that we use is Python and SQLite. And let's have a small demo so that you can get a feel for it.
So hope that it works now.
way which you should show him? Like for English, maybe it would be better to show demo for English.
Okay, I just wanted to show that it's possible to type something like Marathi. Would you like to type something in Marathi and translate?
It's okay.
Okay. This is the setup for iWAS Typing Booster. And first I click here on delete all learned data because it learns from the user input. You don't need, if you use a corpus like Wikipedia, it wouldn't fit very well to the user, so it's much better if one has files which are typical for what that user types, then the prediction gets much, much better. And it's possible to start with nothing at all and just type something. And if you type something similar again, then it is usually,
for example, say
I can almost always choose the first candidate, so I have to type one key and have the whole word already. And
yeah, just a minute. Mike, just a minute.
Sorry?
When you type the comma,
Yes?
did you need to hit the backspace, or if you type comma, it actually...
The backspace was deleted automatically. Like if I type a dot here, you see it has been moved back.
Because I hate that about many other tools that just automatically puts space after the word, but you have to type, you have to hit backspace to get back.
It's the same as the comma again.
Alright.
And so you see it has learned this, after about the next word I type is future. Now of course it's, I didn't type much, so there are not many selections, but users tend to type the same stuff over and over again, so this helps a lot if this is trained by the user input. And to make that training faster, we have option here, learn from text file, so you can use any text file, wait a moment, and it parses this, makes the statistics, and then I used some text here from the Hitchhiker's Guide to the Galaxy, so if you type something similar like that, find the out-charted backwaters, then the program should know that already. It's the second match now, backwaters. So that is pretty helpful if you are typing similar stuff all the time. And I did choose German here, although I typed English. That doesn't really matter, so all Latin languages work the same way. All user input is saved in the same database. So you could type something like German and English completely mixed, and it works because the statistics sees that the two words before were German or were English. And it's a little bit more difficult for languages which need transliteration or a different keyboard layout. Like if you want to type Russian, you would either need to type Latin transliteration or use a Russian keyboard layout. And you can't, at the moment, you can't switch the keyboard layout independently without leaving that input method. So in future, I'll extend the options that you can switch such inputs on the fly. And I want to use Pravin's idea to do some detection automatically. So at the moment, if you want to type Marathi, you have to switch to the Marathi engine and type something. But this could be detected from the user input, because if you type a Latin string which transliterates to Marathi, it's very, very unlikely that this is going to be a valid English or German word. So in future, I think the engine will detect automatically that you meant to type Marathi and do the switch automatically.
By the way, you can choose the candidates. So candidates are nothing but the suggestions by using numbers. As well, you can use the tab to select the first word.
Yes, at the moment you always saw this box popping up showing the candidates, and for some people this is a bit annoying. So there is an option that this candidate box only shows up if you press tab, and then it stays there while you type as long until you press tab again, and then it goes away. So if it gets into the way, for example, if you type something in the browser URL bar or go to Google search and you get some predictions from Google, then this candidate box might hide them, so you can make them go away by typing tab.
Also, that's what actually my next slide was. The current problems with the existing typing booster or the existing projects. The biggest problem that we faced is candidate list itself. Candidate lists are nothing but what you have just seen, the suggestions box. It's called the candidate list. So candidate list often annoys the user because it often distracts. So for example, if you are typing something and sometimes you really don't want to always pop up some message box with list of words. Especially when you are typing on a browser and say you are getting some Google suggestions as well as some suggestions from the input method itself. So it often distracts user, and it's one of the user experiences which we have got. And another problem is good dictionaries, because in open source world we are currently using the Hunspell dictionaries.
Yes, we use them for spell checking, not so much for the prediction, because Hunspell is just a plain word list. It doesn't have trigrams, it doesn't have any statistics, so we can't use it really to predict the next word, but it detects spelling errors. And so if you type something which is close to a correct English word, you will get some predictions from Hunspell what it could be. And apparently in many languages the dictionaries are in a pretty bad state, and Anish is trying to improve them.
And the third problem is uniform experience. As a desktop, while for example for one input method you are getting some suggestions, users often expect some same suggestions to be shown for the other input methods or other desktops. For example, if you are using on-screen keyboard of GNOME, then you would expect the same suggestions to be shown for this input method as well as same for the on-screen keyboard as well. So we are currently working on it.
If you know this prediction stuff from your telephone, then usually the candidates are not a pop-up. They are somewhere above the keyboard in an area where they don't get in your way. So we thought it would be nice, but at the moment it's not possible with GNOME, but it would be nice to have them in a special area somewhere and not at your writing position. So maybe we can do something like that in future. For that reason, I didn't show candidates when you type nothing. So I had to type one character minimum to get the candidate box pop up. In the setup, there was a setup how many characters you need to type. If you think that's too annoying that it pops up after typing only one character and you want it only to complete very long words, then you can set it to a higher number, maybe show predictions only when I type more than 4 characters. Then it's still useful for long words, but doesn't get in the way so much. But on the telephone, usually predictions are shown even when you type nothing. And that would mean the candidate box pops up always. Even if you type something and stop, then a prediction box would pop up for the next word. And therefore, we limited this to 1. But our colleague Pengu had the idea a few days ago that I should show the candidate list nevertheless, even when 0 characters are typed. And if the user doesn't want it, then just make it go away by hitting escape or something like that. It's a good idea. I think I'll add that next week.
I think we have only 5 minutes left, and maybe let's have a question and answer session. Do you have any questions? Yeah, yes, please.
One big question. you have shown this all with GNOME. How much is it wired to GNOME? Because we are asked to implement something like that in Anaconda so that users in Japan can type their names properly and things like that. And we would like to use it in Anaconda. I remember studying it a bit that it was like all the iBus was wired with the decode and GNOME settings daemon.
Yes, GNOME settings daemon, I don't think so. That's
Yeah, only the options, like it's wired. That means in GNOME settings, so you don't have to run iBus setup manually in GNOME.
So the settings are stored in dconf. Is that a problem for Anaconda?
That should be okay. It said that we don't have a user in Anaconda, so they are not user based, but we could probably work around that.
It works in all the other desktops as well. It also works in XFCE or whatever. Actually, I think it works slightly better in XFCE because for some reason I still don't understand, GNOME doesn't want colors in the candidate list. So the candidate list is only black and white here. And in XFCE or other desktops, the candidate list can be colored. So you can have something which is a spell checking correction, can be red, for example, or something which is just an extension of something you type, could be blue, or something you typed before can have a different color. And looks much nicer.
And what about Qt and Key and the other two bits apart from GTK?
It works there as well. In Qt there is one big problem that what's the name for this? Surrounding text doesn't work in all Qt applications. Surrounding text means if I just type one word, next word, then I can predict the next word because I know the history. But I could reposition my cursor. I could use the mouse and put the cursor somewhere else, and then it would be nice if the input method looks at the context and picks up the previous two words. And that works in something like gedit, but it doesn't work in any Qt application, so it cannot get the context from the Qt application.
It sounds promising for us. Okay.
Okay.
This one should be easier. I don't use input methods at all. It's my first real experience with it. What's the state of input methods built into proprietary alternatives like Microsoft Windows or Apple Mac OS X? Is there predictive input methods built into those desktops, or are there?
No. No, they don't have. No, they for desktops they don't have such input methods.
Yeah, I see it always on the phone, but I have never seen it on the desktop. That maybe it is because it's not really necessary for people who can type very fast. I tried myself, so if I type fast, I can type around 70 words per minute in English without making mistakes. And if I have a very good trained this prediction input very well, then I still have to type one letter, look, select a candidate, type one letter, select a candidate, and I try to do this as fast as I can, but I can't reach more than something like 40 words per minute, so I'm barely more than half as fast than when I type without using this. But this is because I can touch type and I know English well, so if I
guess for Windows, they are trying to develop something similar to like this for the touchscreens. That's why I'm not exactly 100% sure about it. Somebody told me that they are trying to do.
So if I type a language I'm not so comfortable with, then I think it helps to reduce the spelling mistakes.
Any other questions?
So does this support Chinese, Japanese?
No.
No.
Not at all. I have no idea at the moment how to do that because what is a word in a Japanese sentence? As Anish already said, there are no spaces in Japanese, so you would need to pass the line in front of your cursor into something which are words and then do the trivium statistics. that's possible. There are tools to do something like that, but still that wouldn't be enough. So I think for Japanese, something like Ueno-san's libkcc is much better, and there's probably no way we can match this in IVAS typing booster.
Other than CJK, all the things are supported, right?
So,
other than CJK, everything is supported.
Other than CJK, actually Korean is supported. I haven't any feedback from users, but I made it work. Korean uses spaces, and Korean has one-to-one transliteration, so there's no conversion step like in Japanese. So you just type some Latin and then you have the exact Korean. So that's so similar to something like German or Russian that it just works. But I have no feedback from real Korean users whether they like it or not. No? Maybe I should ask somebody like Taejun Hyo, or Korean kernel developer. It was a bit difficult to do it for Korean because of the Unicode normalization forms. You type Jamo, and 2 or 3 Jamo are composed to one Hangul character, and you have to look up in the database or the dictionaries, you have to look up the decomposed version, but of course inserting into the text you need to insert the composed version, so this was some back and forth between normalization form D and normalization form C, and so it was one of the complicated languages to support in IVAS typing booster.
Oh, thank you.